So in our march towards introducing kind of some basic elements of calculus, we are taking a look at how we can find the slope of a line tangent to a curve. So some of this that we're going to do at the very beginning here is pretty rudimentary, going back to our Algebra 1 days. But if you'll bear with me, it'll set up what happens at the tail end of our notes and leads into what we'll be working on in the subsequent lessons in the next few days. So to start off with, we've got a linear equation that's given to us here in number 1, y equals 2x plus 1. So if we graph that, we know that the y-intercept is 1, and then we can go up 2 over 1, up 2 over 1, up 2 over 1. So there, well, we can probably try again and do a little bit better there. So there, we hit the line, or the points with our straight lines. There's the graph of our line. And so of course we know that we can use the points that are on the line to find the slope. So if there's 1, 3, and if I go up to 3, let's see here, 3, 7, we can find the slope of that line by using our slope equation. So if we use this as our point 2 and this as our point 1, we get 7 minus 3 over 3 minus 1, which is 4 over 2, which is indeed 2 over 1, or 2. And so we've got the graph of our line. We know from our experience with y equals mx plus b that the slope is going to be 2, and we confirm that with the calculation using that slope formula. So question number 1, we got that done. If we now use a second set of points, so if I now choose to use this as my point 2, so 2, 5 instead of 3, 7, and we do the same calculation, if we calculate our slope, we're going to have 5 minus 3 over 2 minus 1, which gives us 2 over 1. So we get the exact same slope as what we had gotten before. So because the slope is constant along a straight line, it doesn't matter which 2 points we pick, we're always going to get the same result. And so that's the idea behind the question down here, is that because a line has a consistent slope, it does not matter how close together the points are, how far apart the points are, which 2 points we pick along the line, as long as that's a straight line, the slope is going to be the same no matter what. Now, as we've advanced in levels of math, we know that a lot of times we look at equations not as y equals something having to do with x on the other side, but as functions. So instead of it being y equals 2x plus 1, we've got f of x equals 2x plus 1, knowing that this notation is just slightly different, but it means the same thing. But for our purposes, it's important that we start to transition our slope formula as a result into not y2 minus y1 in the numerator, but f of x2 minus f of x1 over x2 minus x1. So of course the output of the function corresponds to the input. So x2, f of x2 is 1 point, and x1, f of x1 is going to be the second point. So we just want to get comfortable with that format. Again, this is setting up what's going to come in subsequent lessons. So our goal, as I said at the beginning, is we want to try to find the slope of a line that's tangent to a curve. And so the idea is if we have a curve and then we have a point right here, there is a line that's going to come into contact just at that one point there. And so we want to know what is the slope of that line. Now, hopefully it's pretty clear that there's only one line that's going to be exactly tangent. And depending where along the curve we are is going to have an impact as to the steepness of that tangent line. So for example, if I was to move up to this point here and draw a tangent line, that line's going to be steeper than the original line that I have there in red. Or if I move to a point right here, I'm going to have a line that's a little bit flatter. So we're interested in what the exact slope of that line is. What is the slope of that tangent line at a particular location? So the function we're going to work with to start off with is y equals x squared. So just the graph of a very ordinary parabola. So the first thing that we're going to do is we're going to sketch that curve from x equals 0 to x equals 3. So if I plug in 0, I'm at the origin. If I plug in 1 for x, I have an output of 1. Maybe the third time will be the charm here. There we go. If I plug in 2, I'm up to 4. If I plug in 3, I'm up to 5, 6, 7, 8, 9. So here is, try that again. Here is my graph. So there's that half of the parabola that we've got so far. And so what I'd like you to do is I'd like you to take a moment, go to this point at x equals 1 right here, sketch in a tangent line, and come up with an estimate as to what you think the slope of that line is, right? If you just sketch that for yourself and then try to eyeball it and see what you think the rise over run is, the way I've kind of drawn it real quickly, it looks like the slope is about 1. You might get something that looks a little bit steeper, a little bit flatter. We're not worried about what the correct answer is at this point. We're just trying to estimate it for that location right here. And typically we'll get answers somewhere in the neighborhood of maybe 1/2 on the low end up to as steep as like 2 or 3 on the high end. So if you got something in that range, then you probably sketched it reasonably well. So now I'd like you to do the same thing, but for now at the locations x equals 2 and at x equals 3. So I've pre-graphed here the half of the parabola that we've been concentrating on. So here when x equals 2, our output is 4, so we're going through that location there. At x equals 3, our y-coordinate is 9, so we're up here. So again, for yourselves, I want you to sketch the tangent line and just do your best to try to estimate what you think the slope of that tangent line is. So if I throw in that line here, I missed the mark, but we get the idea. If I throw that line in here, just want you to do your best on your graph as you sketched it to estimate what you think the slope of that tangent line is. On mine, if I kind of take a look at a little rise over run, maybe here, we've got a run of 2, we've got a rise of 1, 2, 3, 4, 5. So maybe mine looks like it's about 5/2. It's certainly steeper than it was on the previous example. For this next one here, if I go over 1 and then up to here, we're going up, what is that, 8. So I'm looking at a slope of about 8 over 1. So clearly, and hopefully this is confirmed by what you did for yourselves, we're ending up with a steeper line the farther along we go. And that was kind of demonstrated by the kind of general sketches that I had earlier on in the notes. This idea that depending on where along the curve we are, the slope of that tangent line is going to be changing from one point to the next.